is T116 Algorithms and Programming. In this video we're going to be looking at flowcharts and algorithms and how we can analyze this and see if we can look at different types of comparison. So the question here, and the flowchart is shown on the next slide, and also the options for A and B, so we'll come to that. But the flowchart below shows the algorithm that generates and prints a 4-digit decimal number where each digit is randomly generated and also has a different decimal number to previous ones. Which of the following is the correct combination of expressions that can be inserted into A and B in the flowchart? These are shown on the next slide. Here, the function random 0, 9 is used to generate a random decimal integer from 0 through to 9. The one-dimensional array D consists of 10 elements, D0 through to D9. So here we can see the algorithm which we're going to be analysing, and also on the right here are options for A and B, which are going to be inserted into our algorithm here, A here and B here. So let's go through the algorithm and analyse what it does so we can kind of decide what A and B are going to be. So first of all, we start up here at the start command. I will be initialized to 1, and then we'll go through this loop here. The loop j colon 0, 1, 9 is noted here as to what this means. The variable name is shown, then a colon, then the initial value, the incremental value, and the final value. So all this means is that j will go from 0 to 9, and it will be incremented in steps of 1. So d of j is equal to 0. This means that we'll create our 10 element array where each element j is set equal to 0, as j ranges from 0 to 9. This concludes the loop, and we will then enter our main programming loop. Here at A, we'll first of all make a decision, yes or no, and this is going to be one of these 4 options. If no, we will go to the end of our program, and that will finish the program. If A, we will continue into our algorithm. So here, k equals random 0, 9 is used to generate a random number between 0 and 9. We then look to see if d of k is equal to 0. Here what we're doing is we're providing a check to see if the random number k has already been outputted. If d of k is equal to 0, i.e. the number hasn't been outputted before, we will continue to print it. If d of k isn't equal to 0, this means we've already outputted the number. So the no command will be used, and will regenerate a random value for k, in which case we can never produce the same random value twice. We will then print k, and then we will set d of k equal to some value in this B column here, in which we need to decide which it's going to be. I is then incremented, I equals I plus 1, and we repeat the loop. So let's see which values of these we're going to use in our algorithm. Okay, so first of all, let's analyse what our A is going to be. What we want to do is we want to print 4 different values. That was what the question asked us to do. We know that this comparison is going to make a comparison on the value of I, which starts at 1 and is incremented 1 time on every iteration. For this reason, what we want to do is we want to make sure that this condition only holds 4 times, and then on the 5th time we will end the algorithm. So for I equals 1, we want this to be yes. For I equals 2, we want this to be yes. For I equals 3, we want this condition to be yes. And for I equals 4, we want this condition to be yes. When I is equal to 5, we want this condition to break. So this means that these are the 2 options that we have here. I is less than 5. Because when I is less than 5, i.e. I is 1, 2, 3 or 4, this loop will run fine. And on I is equal to 5, we will go down this no option and end the algorithm. Now we're concerned as to what we want to set d of k equal to. So d of k, after k is printed, wants to be set to a non-zero value. This is due to our check above, where we say if d of k is equal to 0, it hasn't been printed before. After it's been printed, we want to set it to a non-zero value, so this condition will still not hold when k is produced to be the same as a previously printed number. So for this reason, we want to print d of k is equal to I. I is never equal to 0, as it's initialized at 1 and only ever incremented. So for this reason, we want to use the option C for our algorithm. So initially, I is equal to 1, j is equal to 0 to 9 in steps of 1, and d of j is equal to 0 for all values of j. Here we're going to use the answer that we derived on the previous slide, that we're going to use A, I is equal to 5, I is less than 5, and B, d of k is equal to I. So first of all, I is less than 5, I is equal to 1, so this holds. The digit 4 is generated randomly, and d of 4 is set equal to I, or equal to 1 in this case, because that is what our value of I is set to. This digit is printed, and then we increment our value to 2. On the second iteration, I is again less than 5, as it's 2. The digit 5 is generated randomly, and d of 5 is set equal to I, or 2, and this digit is printed. I is then incremented, and we have I is equal to 3. Moving to the next iteration, I is less than 5 again, as we're still on I is equal to 3. The digit 6 is generated randomly, and d of 6 is set equal to 3. This digit is printed, and then I is incremented to 4. On the fourth iteration, I is again less than 5. The digit 6 is generated. However, since this digit has already been generated, when we do the check d of k is equal to 0, will return false, as d of k has just been set equal to 3. So the 6 has already been outputted. For this reason, the I is stayed constant at 4, and we will repeat the generation of a random digit. Here, the digit 8 is generated, and so d of 8 is marked equal to I. And finally, this digit is printed, and I is incremented to 5. On iteration 5, I is equal to 5, so it doesn't hold in this I is less than 5 condition. So the loop ends, and we will show how the variables change on the next slide. So here we're using the conditions that we set I is less than 5 and d of k is equal to I in our slots for A and B respectively. Here, the random numbers generated through the program are 4, 5, 6, 6, and 8. Next, we look at the incrementing value of I as it goes through the iterations. So first of all, when we initialize, I is going to be equal to 1, and we initialize all of our values of d equal to 0. On the first iteration, when we go through, we will generate the random value of 4. This means that we set d of 4 equal to I. This can be shown here as d of 4 is equal to 1. On the second iteration, the random number generated is 5, and we will set our value of d of 5 equal to I, so 2. I is then incremented again, and the number 6 is generated, and here again our value of d of 6 is set equal to I. On the fourth iteration, however, we see that we get our value of 6 repeating. Here we do the comparison of d of 6. Is d of 6 equal to 0? Well, we can see it's not going to be equal to 0. It's equal to 3 from the previous iteration. This means that we generate another random number 8 and then follow through with the same algorithm to set d of 8 equal to 4. On the fifth iteration, I doesn't hold through the condition, so the loop ends, and therefore our output is shown up here as 4, 5, 6, 8. So as we can see from our previous answer, the answer is going to be C, and we've checked this by going through what the variables will look like throughout the program. In this video, we've learned how to analyze algorithms and specifically use a flowchart and what these symbols on the flowchart mean.